Hey guys, welcome back to my YouTube channel. In today's video, we're going to be discussing computer storage and the differences between HDDs and SSDs. So let's get right into it. Well, first off, what is storage and why do we need it? Imagine you turn off your computer and you lose every single photo, game, and document ever installed. They're all lost. Well, that would make computers pretty useless. But fortunately, that's exactly what storage prevents. Storage is where your computer permanently keeps your operating system, applications, games, documents, photos, and everything else stored, even after the power is turned off. So once again, storage is your computer's long-term memory. Every single time you save a document or download a game or install a new application, this information is written to a storage device. Now, unlike RAM, which temporarily stores the data while the computer is running, storage is non volatile, which means that it keeps your data even when the computer is completely powered off. Okay, now let's start with the older technology, hard disk drives, or HDDs. HDDs store data on a spinning magnetic disk, and these disks are called platters. Inside of this drive, there's a tiny read and write head that moves back and forth across the surface of these platters, which is similar to like the needle on a record player. As the platter spins thousands of times every single minute, the head magnetically reads and writes data. Because the system relies on moving mechanical parts, HDDs are a lot slower than modern storage technologies. However, they're still popular because they offer a lot of storage at a really low price. So if you need several terabytes of storage for photos or videos, an HDD is often the best option to go for. All right, now let's look at SSDs. Unlike an HDD, a solid state drive has no moving parts. So instead, it stores information inside these tiny memory chips, and these memory chips are called NAND flash memory. Since there's no spinning disks or read heads, an SSD can access the data almost instantly. This makes a huge difference in everyday use for your computer. With an SSD, your computer boots a lot faster, applications will load quicker, games will even load sooner, and files will transfer much more faster. Something important that a lot of people don't take into consideration is that SSDs are also a lot more resistant to being dropped or vibrations from your computer because there's no delicate mechanical components inside of it. Now, not all SSDs are the same. The most common types of SSDs are SATA SSDs and NVMe SSDs. A SATA SSD connects using the same connector that is used for hard drives. It's still a lot faster than a regular HDD. Meanwhile, an NVMe SSD connects directly through the motherboard through something called the M.2 slot, and it communicates through the PCI Express lanes. And because of this direct connection directly to the motherboard, NVMe drives can achieve much higher speeds than SATA SSDs. For example, SATA SSDs can reach maximum 600 megabytes per second, while NVMe SSDs have the capability to go up to 14,700 megabytes per second. But for everyday web browsing, both are going to feel almost similar. But if you're going to be editing videos or moving or transferring massive files or even working with larger projects, then NVMe is going to provide a pretty big advantage. Now, both of these types of SSDs are significantly faster when compared to that of HDDs, which is minuscule in comparison. It's only 100 to 200 megabytes per second of reading and writing to the device. Now, how much storage do you actually need? Well, to understand that, first we need to look at the units of storage. To start off with, a bit is a single binary value, like a 0 or a 1. Now, an important conversion that you need to know is that if you take 8 of these bits and add them up, you get something called a byte. It's just a unit of conversion. And since these single bytes are very small, data is usually measured in much larger prefixes. And these look like kilobytes, megabytes, gigabytes, and terabytes. Now, a kilobyte is 1,000 bytes. A megabyte is a million bytes, a gigabyte is a billion bytes, and a terabyte is a trillion bytes. So these prefixes are used since single bytes and bits are way too small to measure data. So they came up with these words to represent the data. And you'll notice that as you go from kilobytes to megabytes to gigabytes to terabytes, it's just increasing by 10 to the power of 3. You're multiplying by 10 to the power of 3 each time. So these values, these bytes, they're fundamental units of digital information in computing, and it represents an amount of data. Now, how much do you actually need in an HDD or SSD? Well, today, common capacities are the following: 500 gigabytes is for basic everyday use, 1 terabyte is needed for gamers or students who have a lot of files to save or things to save, and 2 terabytes or more is almost always overkill. But unless if you have like a large like amount of games or work with a lot of photos or videos, then this is probably you probably need this. But remember, when you're looking at installing more programs, it's not about getting more RAM, it's about requiring more storage. Now, which one should you buy? If you're building or buying a computer today, an SSD should almost always be your primary drive. The improvement in responsiveness is one of the biggest upgrades that you can make. But if you need a lot of extra space for media files or backups, you can pair the SSD with a larger HDD. And a lot of people actually use this exact combination. They use a SSD for the Windows or whatever operating system, applications, games, and then they also have an HDD for photos and videos and long-term storage that they almost never need to access. So it kind of gives you both speed and affordability at the same time. Okay, so storage is your computer's long-term memory. It saves all your operating system applications, games, no matter if your PC is shut off or on or put to sleep. Hard drives use a magnetic disk to read and write data. So that's why it's a little bit slower and because it has mechanical components. Solid state drives use flash memory with no moving parts, which makes it extremely fast, but it can also be more expensive. And if there's one upgrade that'll make your computer feel a lot faster, it's going to be upgrading from an HDD to an SSD. So that's why SSDs have become the standard storage in modern day computers. And that's going to be it for today's video, and I'll see you in the next one.